Hello, everyone. My name is Dr. Minu Ratnaswamy, and I'm a research engineer at the Space Enabled Research Group at MIT's Media Lab. Thank you for joining us for the sixth and final installment of the Serving Society with Space Data web series, which is focused on real-world examples of how stakeholders from academia, government agencies, industries, NGO, and international development organizations have been utilizing satellite applications and data to support humanitarian and development projects in support of the Sustainable Development Goals. Each webinar in the series has tackled key sectors such as energy, food security, health, and poverty, just to name a few. But importantly, it's brought together experts to share knowledge, provide guidance for decision makers, and highlight new initiatives and areas for further adoption of space applications. For today's webinar, we take a step back and examine how data derived from space can contribute to monitoring projects across all the Sustainable Development Goals, as well as how it can be used to track the Global Indicator Framework. Before we get started, a few housekeeping notes. Firstly, this webinar is recorded and will be made available to the public. The webinar will also be closed captioned, which you can find at the bottom of your video screen. And finally, the web series has been reaching a global and multi-sector audience. And we want to ensure that you're engaged with the discussion. So once again, we'll be using the Slido web platform to run a live audience poll question during the webinar, as well as allow time for audience Q&A after each of the panelists has made their presentations. So we invite you to go to Slido either on the app or the website and use our event page #SDG. Now, many of us are already familiar with the Sustainable Development Goals and know that within each of the 17 SDGs, there are a range of targets that serve as guidelines to help governments at really all levels to develop implementation strategies and allocate resources accordingly. Progress towards these targets are measured through a set of indicators for monitoring performance. However, tracking the progress towards SDGs and its associated 169 targets through 231 unique indicators have challenges of their own. This includes the lack of baseline determination, counterfactual selection, and avoiding selection bias. Earth observation data, methods, tools can, and already, is providing an accessible, comprehensive, and communicable data source of information for SDG project planning, monitoring, and decision making. So as usual, we kick off our webinar with a poll question to the audience. And today we're asking our audience to identify a few challenges that they might think would hinder the use of space data for SDG monitoring or an evaluation. So please go to the Slido app or webpage using the event #SDG. And please vote. We'd love to hear your opinion. Now, our panel of experts will be describing their use of geospatial approaches, Earth observation data, and big data analytics to keep track of the progress towards humanitarian and development projects, including how Earth observation can provide decision makers with data to make better policy decisions to increase progress towards all of the goals. So we start with our first panelist, Dr. Ajiro Kavada, Program Manager of the Earth Sciences Division's Sustainable Development Goal activities at NASA. RG also leads the Booz Allen Hamilton's project on studies, assessments, and strategic management for the Applied Sciences Program in NASA's Earth Sciences Division. She serves as the Executive Secretary for the International Earth Observation for Sustainable Development Goals, EO4SDG initiative, and serves as the NASA representative to the Committee on Earth Observation Satellites SDG Working Group. Aji, thank you so much for joining us today. I know you're extremely busy, and I know that you're actually cutting short one of your other meetings to join us today. So thank you very much, and we look forward to learning more about your work.
Thank you very much, Minu. It's a great pleasure to be here, and hello, everyone. So first of all, I do want at the beginning of the presentation, I wanted to invite you to visit our website at eo4sdg.org. And also, if you have a Twitter account, take a look. And if you're interested in Earth observations and SDGs, please follow us on Twitter at eo4sdg. So very excited to be here today, and we can move on to the next slide, Minu, please. And so, Minu, you have already provided an overview of the SDGs and their associated targets and indicators. The only additional element that I can add here through this introductory slide is the particular relevance of the SDGs as an organizing framework, especially during this particular year with everything that is happening with the global pandemic and the efforts worldwide to address this pandemic and also in the future recover from it and building more sustainably and resilient societies. And so in particular, the SDG report 2020, which is a global stock-taking annual report, highlights the impacts of the pandemic on countries' efforts to achieve the SDGs, in addition to the uneven impact of COVID-19, particularly on the poorest and most vulnerable. And so I just wanted to highlight this to bring this into the context of today's conversation and note that the UN and the UN Secretary General has particularly highlighted the need to use sound data and science to help address the impact of the pandemic and recover from it, and also use the SDGs as an organizing framework in doing so. So in the next few slides, I will be briefly reviewing some guidelines on existing data flows and SDG reporting processes that have been set up at the global level by the UN, and also discuss some opportunities and efforts to integrate Earth observations in support of SDG monitoring and reporting processes at both the global, regional, and country level. Next slide, please. So in this slide, I am showing you, so this is from the guidelines on data flows and global data reporting that has been developed by the Interagency Expert Group on the SDGs. And you can see here one of the key fundamental roles that the 2030 Agenda places on country-led evaluations and data to inform follow-up and review processes. And so in that, the role of national statistical systems is highlighted as the entities that collect data and help produce comprehensive set of integrated statistics, which can then be utilized for international aggregates. And so the regional mechanisms, including UN Economic Commissions at the regional level, help facilitate then this data transmission process from the national to the global level, in addition to helping identify specific gaps that may exist at the regional level, in some cases when needed, developing regional indicators to complement the global SDG indicators, and facilitating peer learning through the sharing of national experiences. In addition, you see the role of international agencies, which help compile comparable international data series, calculating global and helping bring the global and regional aggregates in order to track progress on achieving the SDGs, along with helping put together metadata on how countries can be achieving or monitoring and tracking progress on the SDGs. In addition, these agencies help prepare the storylines for the annual global process progress reports that are being produced to assess how countries across regions are doing with respect to achieving the targets and goals. Next slide, please. And so in Earth observations, so we have been working within the extended Earth observation community with the UN and the statistical and geospatial related committees at the UN level to help showcase how Earth observation data can be supporting the SDGs. And so Earth observations acquired both through remotely by spaceborne sensors or airborne devices, in addition to in situ sensors and ground-based observations, represent valid and globally consistent sources of information for monitoring the state of our planet, and can help provide or serve as inputs to directly inform indicators, in addition to supporting and augmenting statistical data, helping improve the production process of statistical information and validate that, but also communicating and visualizing the geographic dimensions and context of the indicators where appropriate. And so you can see here on the right-hand side a table that showcases different types of related observations that are relevant to addressing the 17 goals and associated targets, including, for instance, assessing changes in land use and land cover changes, looking at oceanographic related observations, or observations that relate to air quality and health. And so, in addition, what you see on the left-hand side of the slide are some of the challenges and the commonly stated obstacles in really getting Earth observation data being used widely by countries and relevant stakeholders in both driving progress and tracking and monitoring the SDGs. And so we recognize, and you can see here some of these challenges that to the Earth observation data and the human and technical capacity to process them. And so a lot of strides have been made toward addressing some of these challenges, for instance, in terms of open data policies and the provision of free Earth observation data. Both the US and European governments have been are providing freely available open data, and so this has helped make a lot of Earth observation data available, an aspect that is particularly useful for developing countries, in addition to, of course, developed countries. And so we can talk more perhaps during our discussion session about some of these challenges and efforts that are being currently underway to tackle some of these through international collaboration. Next slide, please. And so one of the initiatives that I wanted to highlight today, and I serve as the executive secretary for this initiative, is the EO4SDG initiative, which is an initiative within the Group on Earth Observations, an intergovernmental organization of countries and participating organizations that focuses on advancing global knowledge about effective ways that Earth observations and geospatial information can support the SDGs. And so you can see that particular focus through this initiative is placed in working with the statistical community, both at the global and national level, in addition to, where necessary, working at that subnational level as well with cities and municipalities, for instance, to address a lot of the urban-related SDGs, among other areas, and UN agencies to help both support EU integration in methodologies, but also help in terms of piloting and testing these methods and supporting capacity development and skills development to enable the use of the data in support of the SDGs. You can also see many of the contributors to the initiative on the left side of this slide. Next slide, please. So in the next couple of slides, or a few slides, I will show you a few examples of work that the Earth observation community has been making in addressing the SDGs through the use of Earth observations. And so the first example here is on SDG 6, and in particular, a target and indicator that focuses on changes on water-related ecosystems. So through a collaboration among the UN Environment Programme and the GEO and broader Earth observation community, there have been several developments in refining and integrating Earth observation data into a step-by-step methodology that helps countries see how they can be applying Earth observation data in combination with in situ and national data that they have on tracking progress in changes in the extent as well as quality and other parameters of water-related ecosystems. And so through this work, we have been placing particular emphasis in ensuring that countries have access to tools and knowledge about Earth observation data in cases where they may wish to perform their own national monitoring. And in addition, there are several global reference data sets that have been, that are available, and they are made available through this portal, SDG661.app, that you see a screenshot of that on this slide. In addition, we're working through the collaboration of different space agencies and the Committee on Earth Observation satellites to identify specific observation gaps and challenges, in addition to helping integrate more existing or upcoming global data sets of relevance to this indicator. One example is the recently published global maps of drivers of mangrove loss between 2000 and 2016 that was published by a NASA team led by Liza Goldberg. Next slide, please. So in the next slide, I also wanted to highlight the work that the Group on Earth Observations Blue Planet Group has been doing with the UN Environment. And so they have been working to help produce statistics for global indicators that relate to coastal eutrophication, and also developing a dashboard to serve as a eutrophication decision support tool to help identify eutrophication hotspots. In addition, they are also working through a separate collaboration to look at marine litter and help develop a platform that focuses on monitoring marine litter. And as part of that effort, they're also working with the Wilson Center to visualize and analyze marine litter data from community-based cleanup efforts. Next slide, please. Another effort that we have been focusing on has been on how Earth observation data can support urban-related SDGs in addition to the new urban agenda. And so you can see here a collaboration among EO4SDG, UN Habitat, and several geo-urban work program activities and other partners. And so this collaboration focuses on developing a toolkit that can help identify local monitoring needs by working together with a selected number of regionally representative cities and countries, and shares guidance on relevant data sets and tools, as well as good practice examples and use cases of Earth observation data applied to address urban-related SDGs. And you can see some of the key components of the toolkit that we're currently working on highlighted on this slide. You can also find more information on the concept paper behind this GeoSDG toolkits at the link provided at the bottom of this slide. Next slide, please. In addition, I wanted to also highlight one particular project from several projects that serve as demonstrations at the country level. And so this particular one is funded by NASA Applied Sciences and focuses on working with Belizean government entities in enabling and helping build capacity in using Earth observation data, including optical data sets as well from satellites, as well as in situ measurements of coral reef extent, water quality, and nutrient load measurements to help Belize assess SDGs that relate to both goals 14 and 15. And so in particular, this project is working with the Coastal Zone Management Authority and Institute in Belize, who is one of the main, or who is the entity responsible for monitoring coastal and marine water quality in Belize. And as part of this effort, a couple of items that the team has highlighted here is the need for further coordination with entities that are serving or are responsible for the monitoring and data collection side, and the ones that are responsible for reporting at the national level on the SDGs, as well as up to the UN level. And so we are working to facilitate this communication of the efforts and results of this project. The last slide that I have is on this special issue that focuses on Earth observations and SDGs that we've developed in collaboration with the University of New South Wales, as well as CSIRO and the Committee on Earth Observation Satellites SDG group. And so this one, this issue presents so it presents a total of 17 papers and an editorial on how EO experts are working to help integrate Earth observations in different SDGs. And you can see that some of the key SDGs that are covered in these issues, most of the papers have focused on goals 6, 15, followed by 14 and 11. I will, in the interest of time, I will stop there, and perhaps we can discuss more about this as well during our discussion time. So thank you very much.
Arjit, thank you so much. What really strikes me is that in nearly every single slide that you just presented, you talk about collaborators and contributors, whether they're UN agencies or regional commissions or countries. And it's really fantastic to highlight all of these different stakeholders that are coming together to optimize and utilize different types of space data for monitoring and evaluation. So thank you so much. And I also am so glad that you mentioned the special edition of the journal. I've used it as a fantastic resource, and I really encourage the audience to look out for it. It has really comprehensive case studies and research on this particular topic. So Arjit, thank you very much.
Thank you. Thank you.
So I'd like to remind everybody to respond to our live poll question and submit your own question to our panelists on Slido using the event name #SDG. Our next panelist is Hansdeep Khaira, an evaluation officer in the Independent Office of Evaluation of the International Fund for Agricultural Development, or IFAD. Hansdeep works on a variety of ex-post evaluations, including country program, project, and impact evaluations. And since 2016, Mr. Khaira has led evaluations in Georgia, Kenya, Guyana, and Sri Lanka, and has pioneered the use of geospatial analysis in IFAD's Independent Office of Evaluation. Hansdeep, thank you so much for joining us today. We really look forward to hearing more about your work and how you've been able to integrate geospatial data in your projects.
Right. Thank you for the introduction, Meenu. Hello to everyone. So what I'll be presenting today is more of a practical example that of an evaluation that I had conducted in Georgia, the country Georgia, a few years ago. And essentially, I had made use of this particular, geospatial analysis for the first time. Just to give you a sense, the IFAD is my organization is one of the UN agencies that's involved in giving. We are in the field of agriculture. We promote agricultural development through projects. And the main aim of our projects, essentially, the development goal is to increase assets and incomes of rural farmers and improve their, improve their lives. So in other words, we contribute to SDGs, especially to 1 and 2, which is about poverty and zero hunger. So this particular project also had the same development objective, development goal. Its main objective was the rehabilitation of dilapidated irrigation canals, that bring water to the farms. They were in a state of disrepair, so the project, the project, improved these irrigation canals. And as a result, water started flowing, and the aim was then agricultural production would increase. With the increased production and area, the farmers would be able to sell more and therefore increase their incomes. Now, the Independent Office of Evaluation, where I work, we undertake ex post evaluations. In other words, after the project is over, we go there and see what has been the effects of the project, the benefits. And so this was exactly the objective of this evaluation also, to measure the economic changes in the lives of project beneficiaries, and looking at income and changes in agricultural production. And basically, the idea was to, because this was an impact evaluation, it was a quasi-experimental impact evaluation. In other words, we basically conducted a household survey, and it was ex post, so we had to recreate control group or the comparison group, and we had information on treatment group. And as Meenu had mentioned earlier, the issue still plagues a lot of development projects where baselines are either not done or they are not accurate. So we also had the same problem. So, and in that respect, I decided to use geospatial data. The idea was to use it as an innovation, is also just to what we call the triangulation of data. So it was not the main method, because we hadn't tried geospatial analysis, and we did not want to do it entirely on its as a standalone. So we used it for two purposes. One was to select the control group of households, basically at a geographic level. And the other objective was to then triangulate the results that we got from the household survey and see if the data matched this, what we had got from the household survey. So basically there were two main objectives. Now, for the use of sampling, which was to select the control group, we looked at geospatial data using Google Earth, and we kind of identified clusters which were nothing but villages, and we kind of matched them on geospatial characteristics. Let's say looking at the average elevation of the village, what is its distance to a primary road, what is the distance to the market. We also looked at Köppen climate classification. So the idea was to, based on these external physical characteristics, to then match it with the treatment group. And once this was done, the aim was then to go and conduct household surveys there. Now, when it comes to the second purpose, which was to validate the results of household survey, this was then one of the questions asked in the household survey was, to farmers was, so have you increased the land area? Because the idea is, as soon as water flows or there is more water available for irrigation, the first thing farmers would do, if they have area available, they would increase the area under cultivation so that they can grow more. And so geospatial analysis was used to, we wanted to estimate the magnitude and the difference in the land cover. So the idea was to look at geospatial images and see the area that was under cultivation before the project started, and to look at then the area which was after the project had finished. And this would give us a sense of whether there was any difference. And we also had the same thing for the control group, and I will show it through a slide later. So we looked at both control group and treatment group, and before and after. So if somebody, people amongst you are familiar with impact evaluation, there was something like a difference in difference method that we had used. And we basically used the normalized difference vegetation index, that is the NDVI. So essentially we were looking at, in layman's term, we were looking at what was the change in the greenness of the targeted land area before and after. So the greener the area and larger the area, it would mean that the project had a kind of a beneficial effect on this. And for that purpose, we used the NASA MODIS satellite. And I must mention, we had to use now MODIS does not give you very close range. It gives you observations from 250 meters, which may not be very, very clear in terms of how highly granular. But because we had to go back in time and, we went back as 2004 and we wanted to see what changes have occurred, we had to use NASA MODIS because that was the only satellite data that went back if we wanted to have a time series. And as I said, we used the difference in different methods to see what was the change. And while this gives you an idea, your geospatial, but if you actually have to calculate in actual terms what is a numeric value, we use the R program for that. We use the root RMSE for actually looking at the difference in the two, and we arrived at that. And next slide, please. Okay, so this particular slide then shows you, you see the green areas. These are the ones that are the what do you say, the irrigation schemes that the project had, had intervened in, and farmers in these areas had received, let's say, more water coming in, and based on that, next slide, please. And based on that, we then, if you see the portion inside the white boundary, that's the treatment area, and within those we selected different field sizes, so medium fields, large fields, small fields, and then we looked at the area immediately surrounding this containment area, what you may call. And those were, which you see in yellow, those were the control groups. So we looked at kind of similar elevation, but as you know, in agriculture, similar agroclimatic conditions are key. And for that, we had to choose areas which were closer to the treatment area so that the agroclimatic conditions would be similar. Next slide, please. And basically, the next slide shows you the results, in short, on what we achieved after we used the R program based on the images that we had received. So on the first column on the left-hand side shows the various schemes, and you see different colors. So the ones which are in dark green, those were the areas where we noticed a difference, and that's the third column. Now, a negative actually here means that area increased more. It shows that there was some activity, additional activity, and these ones in dark green were also statistically significant as as depicted by their p-value. So based on this, we kind of found out that there had been several areas which had actually had a positive effect, and we found out this through using the geospatial analysis. The next slide, please. So to conclude now, basically what we found was the results that we obtained from geospatial analysis were quite similar to those that we got from household survey. So the farmers told us, well, we did not increase the water so much, we did not increase the land area so much. Well, the reason for that was they said simply markets were missing. So even if we did increase the land area, where would we sell that to? So that was a lesson learned that development interventions have to be more holistic and kind of more comprehensive. But this also matched with the geospatial analysis that showed us that roughly only 2% of the area had actually increased. So this was, for us, this was great news that it kind of, we were able to triangulate the findings. And basically what happened is, as I mentioned earlier, we essentially looking at it as a geospatial analysis in tandem with household survey, because we were not sure what would have happened or what the results would be, but we were very happy that results were similar. And later on, we actually used this for several other projects where we used it as a standalone method because our confidence in this method had been reinforced. Next slide, please. So some of the challenges and lessons we learned was, firstly, it's very important to have accurate geographic coordinates, right? Because without the white area that we showed, because without accurate coordinates, it's almost impossible to know where the project area was. And for this, we definitely need good monitoring and evaluation systems in place. Without that, it's almost impossible. And I must tell you that I'm an evaluator, so I do not have specific evaluation, geospatial kind of skills, technical skills. And so I was able to collaborate with another person, another colleague from my organization and do it. So just to say that for doing such kind of work, specific technical skills are required. Now, while we were able to see the difference in the greenness and, difference in the area, if we were to look at or analyze something more complex, for example, has there been kind of any change in the has there been any change in the let's say type of crops that were grown? That would have been impossible from 250 meters. It cannot tell you. Well, of course, the advances in technology with heat mapping you can make out, but so far if the farmers switch their crops from one to the other, that was not captured or would not have been captured by spatial analysis. And again, just to conclude, and the uses of space data are several. I mean, when access is denied to locations, difficult and hard to reach areas, we can definitely use it as a standalone method. But importantly, it can also be used for when we are looking at sustainability of infrastructure projects. So, sustainability of projects go beyond the projects, right? So when donors come in, they emphasize on idea, they go away, then, we do not know what's happening. But and also monitoring evaluation units have been disbanded by then of the project. So that's very difficult to know. But then that's where geospatial analysis comes in, which can actually freely tell you what has been the sustainability of the project, even after several years of it having been completed. That's all. Thank you.
Hans-Diep, thank you so much for the great insight into ex-post evaluations. What really struck me is that you said that development projects need to be holistic. And I think when we think about monitoring and evaluation, we can often be caught up on specific targets and specific indicators and sort of lose sight on the overall mission of what we're trying to do. And you talked about, agriculture, you also talked about the change of income. And I think this further emphasizes how interlinked so many of the SDGs are. So thank you so much. I know that there's a couple of questions already coming in through our Slido app for you. So be happy to reach out to you in that portion of this webinar. So thank you very much, Hans-Diep.
Thank you.
I'd like to introduce our final panelist, Dr. Diego Silva Ardila, who's the Professor of Urban Studies Program at the Universidad del Rosario in Bogota, and also coordinates the development of CEPI's data lab for the UN COVID-19 Multi-Partner Trust Fund's Center of Development and Innovation. Diego is also the former Deputy Director of the Colombian National Statistic Institute and joins us today to provide a few case studies for Colombia. So Diego, thank you so much for joining us and also really eager to hear about some of your work.
Looks like you're on mute there.
Hello, Minu, and everyone who is with us today. As Minu mentioned, I'm presenting from CEPEI, a Global South think tank working from Colombia. And I would like to use this time to present on the way Colombia, the country, has been using space technologies to promote better representation, conceptualization, and understanding of the territorial dynamics. I know it's a long title for a brief presentation. I'll try to do it really brief. So if you help me, Minu, next. These are the 5 ideas I would like to introduce. I won't read them right now because we will have them in each of the slides, but basically it's the structure of what I want to discuss today. Next. The first idea that I want to convey is the idea of the challenge that we have today with the science of cities. Many years ago, large and important cities all over the world, such as Buenos Aires or Mexico City, or other cities like London or New York, start having different ways to approaching their big growth, their big industrialization, and bird's-eye views allow to observe the dynamics of those developed cities in a different manners that, of course, monitor the process of large expansion and economic development. If we move to the next one, just to jump many decades, that's something that we have today. And it's not only about having images or having the capacity to locate the business that we would like to visit in the coming hours, which is also a really great tool. But now we have the capacity to do a exploration and so-called science of cities. And probably most of the audience here know that. For many of us, we think that the capacity that we have today is not fully employed. And that's a little bit what we need to work together and what we have observed in the former presentation. This image is taken from the New York University project, the Urban Expansion Atlas. I will comment later because they have worked in Colombia in the last years. If we move to the next one, Minu. The idea of the representation, I brought some images, I had them animated, but I can explain it one by one now, is moving from naive approaches. The first one is the way my son represents a crab. My family thinks I'm good at painting. The second one is mine, I do not think. And the last one is the representation of a specific function of analyzing and studying the crab. So each one serves different purposes, different moments of learning stages. But at the end, we know that each one has completely different functionalities, and representing also highlights the potential that we have in using the knowledge that we have from the phenomena that we observe. So if we move to the next one, this is the next one. This is the way in Colombia, and probably in most of your countries, we represent territorial dynamics, which I want to make a parallel with the crab that my kid paints. These are, and you will see it later, what I call 19th century representation of the territory. I know they are functional. I know that's the way we elect mayors and city councils and many other things. Actually, we don't elect city councils. We elect municipal councils, which is different. And that actually poses a big challenge to understanding territory, measuring it, and actually applying SDG goals and monitoring schemes. If we move to the next one, this is a little bit the image that I want to bring to reinforce my argument. The map on the left side is a traditional 3D map of Colombia. Colombia, like many other countries in the world, is one of those countries that can only be understood if we observe it from a three-dimensional perspective. If we use only flat perspective, it's really wrong to analyze Colombia. And this is the urban area of a big important city named Buenaventura, with a lot of inequalities and specifics in the territory. But in this moment, I want to highlight that that red dot that we have on the image on the right side, that's the urban area. And the yellow area is the municipal boundaries. That municipality, that mayor, that city council had to arrange their policies to manage rainforest, agricultural land, urban areas, one of the largest ports in Colombia, and everything related on the concept of municipalities. For many years, if we can move to the next, those red dots, we used to call it in Colombia, urban cabeceras, urban areas. And the rest of not red areas, it was called literally rest. When you call the rest of your country just rest, that means that actually you do not understand that area. So in 2014, Colombia, after solving many issues of violence and conflict we had in the countries, we were able to walk all over the country and do the national agricultural census. And that allowed us to have a better picture of the country. And we did it, of course, walking the territory like traditional statistical techniques, but we were highly using spatial data to have the frames where we were analyzing. And now we have a better picture of the areas that are not urban and understanding how we are located. So I would say that is one of the initial moments that complement, if we move to the next one, the initiatives that we have in Colombia of understanding better. If somebody is interested, you have all this platform and all that information available in a really, really powerful tool in the Colombian Statistical Office. If we move to the next one, that was an initial moment, but basically we were trying to solve the tension between municipalities, the representation, what I call the 19th century representation, and more 20th century or 21st century ideas of understanding human dynamics, continuum, or what we call a functionality. If we move to the next one, probably we share this problem in many locations all over the world. And this is a city that many of you know. This is Medellin. We are here using the traditional lights satellite image. You can see the extension of metropolitan or large urban agglomeration of the city. But sadly, the only policy unit that we have to govern that city as a unit is that yellow dot polygon. That's what we technically call Medellin. So actually, to manage to observe this city, to apply SDG technologies to this city, we really need to work with many other municipalities to understand the complexities of the urban phenomena. If we don't, and let's move to the next one, we continue using 19th century approaches of policy development, which at the end provides what I call Excel spreadsheet ways of planning, which at the end do not solve the challenge that we have. So let's move to the next one. Colombia, as a country, have understood that challenge. We have used many of the ideas. Here I'm using an academic reference of how the dynamics of urban things happen in Colombia. But the map in the center is actually the framework that the Colombian government and the National Planning Department use it in a model called the system of cities. And the system of cities allows to modify the way Colombia plans its territory. And it's a new framework that, although it's not totally widespread within all authorities in the country, is one of the reference that now is trying to be allocated in the territory to move in the coming years to network approaches. I'll just give you just briefly to finalize this presentation, a couple of examples. Let's move to the next one. Oh yeah, I'm good on time. I have 1 minute and I have only a couple of slides, so I'm done. First one, new ways to approach the city. Here, we're seeing different ways to understand, for instance, the biot between Barranquilla and Cartagena on the Caribbean coast, and understanding the symbiosis between the territories, Medellin and the dynamics with the territorial cities that are around it, Bogota or Cali. Just a little bit of understanding that this is not about cities and the rest, but this is cities and the territories surrounding, which are mountains, lake, agriculture areas, preservation. And that's really important to use it using spatial technologies. If we move to the next one. One of the initial projects that the Colombian government had using the framework of the New York University expansion project that I mentioned at the beginning was to apply a little bit of science of cities to understand how Colombian cities have grown. Next one. This project, and Colombia is one of the only countries who have been working comprehensively of this project, allowed policymakers in Colombia to explore how Colombian cities have been growing in the last decades. What are the processes happening in each of the city? Which one is built area? Which one is infill? Which one is a leapfrog? Which one is inclusion of urban areas? And having statistics to approximate the science of city. Next one. The Observatory of the System of Cities, that project that I mentioned that is based in the National Department Planning, has been developing new battery of information, understanding the concept of cities, and leaving aside a little bit the municipality. We still have to do it. So you can see on the selection thing that you can still select municipalities, but you can also select the system of cities and start seeing the networks that emerge within that system. This is, for instance, the service areas for births, how people commute from different locations to have births of the children. And that gives a little bit of the map of the health system in Colombia. And just to finalize and tell you a little bit of the experience of CEPEI, next one. Colombia luckily finished a population census last 2 years, and they developed the multi-dimension poverty index by block using that information, traditional information. CEPEI, and working together with the DANE, has been working on developing capacities to start exploring special technologies to use methodologies of observing poverty areas as a proxy, the satellite image. And now we have a contrast layer of information, this one coming from the census, to see if the forecast using spatial technologies relates to what we have seen in place. 3-4 months ago, we finalized the workshop with DANE, and now we're trying to start doing the follow-up of the project. So the next one, which is the end, thank you very much for the invitation. and ready for the conversation.
Diego, thank you so much. It's great to learn about the system of cities and your work as well, and also how you've been able to use satellite data as a new layer of information to validate, as you said, the survey data, but also as a catalyst to have these conversations with some of the key policymakers. And that's definitely a topic that I want to come back to with regards to some of your work. So as I had mentioned, please go to Slido using hashtag SDG to also ask your questions. I want to now reflect on the poll question that we started running at the very beginning of this webinar, and we had asked the audience to think about what some of the challenges that they might find in limiting the use of space data for SDG planning, monitoring, and evaluation. And Arji, maybe I'll come to you because I know in one of your slides, actually a number of your slides, where you had little post-it notes with the challenges, capacity building and capacity gaps was listed as one of your challenges. So could you talk a little bit about how the space industry, NASA, and the work that you're doing are really pushing forward to alleviate this particular challenge?
Yes, Minu, I'm just trying to just get back off mute. Yes, so so in terms of, as mentioned, so we have been, we are working through collaboration and partnership that involves stakeholders at the country and the subnational level as well, in both testing and seeing how global methods or specific data sets can be applicable within a country or in specific cases, city context, but also to identify where there may be needs and gaps. And so certainly through developing and helping share, so both developing some good practice examples that others can consider and pursue, but also through helping share information on such good practices and innovative approaches. And so some of the things that both within the GEO and CEOS community we have been working on have been to capture such good practice examples and to also help develop others in collaboration with country partners. And so there are some use cases available, for instance, through the EU4SDG website. I highlighted the toolkit effort that is currently one of the pilot toolkits that we're currently developing is the one with UN Habitat. And that particular one is really aiming in facilitating this cross-sharing of national and subnational and city experience with the aim of fostering more coordination across EU experts and then country level and city level stakeholders, as well as decision makers on how Earth observations can support specific SDGs.
Thank you, Arji. And I think the use of use cases is so important because for many stakeholders outside of the space industry, seeing a use case that they could customize to their own needs really puts things into perspective and helps them sort of think of new ways to use this data that's customized for their projects. I know that Hans-Diep also, when he did his presentation, talked about how capacity, because he wasn't in the particularly, the technical field, there was somebody that he had to reach out to. And I think that we should definitely be aware of capacity building, even if it takes a longer time to do so. Arji, I might stick with you. So I have a couple of questions for our panelists, and then I'm going to throw it over to the audience. Arji, what are some of the steps that we can take to strengthen collaboration across scientific assessments and countries to combine statistical, geospatial, and Earth observation data in order to really allow Earth observation to function as a key enabler for Agenda 2030?
Thank you, Mino. One of the main things that was also highlighted in that last slide that I showed on the special issue, and, we've assessed through that editorial we've put together on that issue, is the need really to focus on working and helping countries apply the data within their own context. And so focusing really on the interpretation and knowledge aspects, in addition to providing the data and then helping, garner information from the data, but really transitioning from that data and information to knowledge and how that can be applied to inform policymakers or to inform policies and support policymakers in driving policies. And so there is this process that the scientific community, in collaboration with international networks and relevant stakeholders in countries, can focus more on really helping establish potentially this workflow that takes us from data and information to really acquired knowledge that can support countries in driving progress, monitoring and tracking progress on the SDGs, but also in the SDG implementation.
Yeah, just on that, on that word knowledge, I have another question. So I want to come back to the special edition of the journal that you had mentioned during your presentation. And one of the things that was mentioned is that it calls for a need to transition towards new Earth observation for SDG frameworks that are focused on the knowledge element rather than the data and information aspect, especially when we think about the data, information, knowledge, wisdom paradigm. I'm wondering whether you could talk a little bit more about the differences in your work between knowledge and data and information.
Yeah. And so, it's really in that graph that I had showed, which also leverages work completed by Graciela Metternich, Stefano Nativi, and others. It's really, again, focusing on first deriving information from data and processing the data to generate information in the form of relevant physical parameters, and then helping translate these into knowledge that can inform or serve as a direct input for one or more of the indicators that can then inform a given target. And so really translating that into how that can be applied to assess and evaluate the progress toward meeting that target within a specific country setting is different to a research project that does not really involve that engagement and application at the stakeholder level. And so that's really one of the key steps that were more ought to be done in order to enable a broader use of the Earth observation data at that level. In addition, there is certainly, we've talked a bit more about the peer-to-peer learning, and so certainly nurturing that community that can help enable that in terms of both helping countries share common challenges and identifying also good practices by engaging both developed and developing countries, and structuring those discussions is certainly key. In addition to advocating for and helping share testimonials that showcase the impact of applying the data.
Thank you, Aji. We have a couple of questions directed to you from our audience, so we're going to try and get through as many as possible. Hansdeep, I might turn to you for now. So you mentioned the fact that you used geospatial data for the first time in this project. And I'm wondering what you learned from this experience in utilizing geospatial data And what changes would you make if you had to start a similar project?
Right. So your first question was, what did we learn, right? And that was basically that, basically what we learned is that the geospatial data analysis can be actually used as a standalone method. You may recall that we started as a method that triangulates what it was like a secondary data collection, if you may, to the main data collection, which was the household survey. But having been bolstered by the results of geospatial analysis, I think this is the learning that it can be used as a standalone method. On the other hand, like I said, there are some things you need to bear in mind. For example, you need to have geographic coordinates on the ground, and without that, especially when you're looking at localized projects or localized areas, if you want to look at certain geographic areas only, then you will need those specific coordinates if you're zeroing on into something. So that remains a requirement, and in future projects, and it took us, like I said, you don't have monitoring evaluation units usually which are functioning perfectly the way you want them, and as a result the data is not always with them, and so it's very important to prepare in advance for such information, because I remember we had to really expend a lot of time in trying to get this M&E data from them. Even simple geographic coordinates of the areas where projects where the project had been implemented was difficult to come. And I think it's, in the future, if I were to do it again, I would ensure that, I collect all this information in advance before I actually undertake the geospatial analysis.
Thank you, Hansdeep. And just in that line of thought, in your presentation, you talked about a household survey. We're in the time of COVID right now, and we're aware of the importance of adaptability and finding alternatives to traditional data collection methods. In your opinion, how can we better utilize geospatial technology and data as a tool for evaluation, where we can't currently go and do those household studies?
Right. So again, to reiterate that, we found that this, geospatial analysis could be used on its own, and in the future, especially when it comes to hard to reach areas and etc., we can actually use this data comfortably. Having said that, one also has to remember that our projects or rural projects or rural development projects are integrated projects, which means they do a number of different activities, and there are certain activities that lend themselves to geospatial analysis, some of them don't, right? For example, if you want to find out how did specifically at the household level did income increase or not, you actually have to go on the ground and speak to the people, so anything that is physical that can be viewed from top that can be used, it can be used definitely for that. But there are certain aspects you cannot, other interventions like what was the impact of rural finance, on villages. You really cannot measure that through satellite data, right? So there are certain limitations of this. While you can use it, in several places, but you also have to be mindful that there's only so much you can do with it right now.
Thank you so much, Hansdeep. Diego, I might come to you next. So you talked a little bit about different government units and how they had defined the system of cities and also municipalities. How have other governmental units reacted to this conceptual framework and to the set of disaggregated information?
Minu, a really interesting question, because it's hard to answer in one line differently. But I would say that, of course, when modifying the way we represent our ideas and our knowledge, but also in terms of policy, the way we represent our interests, there is tension, because behind the policy is politics. And that's the way resources, priorities are allocated in the territory. So not even the units that we mention as the ones that have promoted the methods have integrated this idea comprehensively. So has been running in parallel. Some others have been opposing, or some others have been even neglecting the possibility of reorganizing the way we think ideas. But I think that contemporary challenges, and especially the ones highlighted by the SDG goals, are so large that it is impossible to neglect an approach of functionality of the territory dynamics and the complexity behind it. So disease, and actually COVID is a great example, but for instance, in Colombia, we used to have a couple of examples of cities having high levels of dengue fever similar to rural areas that should not be happening in a city with all the development that we have. And that's basically because mosquitoes don't know the boundaries, like COVID doesn't. You know, so COVID moves through complex networks. They don't respect municipality boundaries and say, oh, okay, here is where Medellin ends and the next one is Envigado, so let's stop here because the measurements in Envigado are better than the ones in Medellin. That's not the way it works. So it's really hard to neglect it. And slowly, all of the governmental units, national, regional, and local governments, but also sectoral ones, agricultural, commerce, have been responding positively to the proposals.
Diego, fantastic. And I actually want to jump ahead because we had an audience question that I think is very relevant to what you were just talking about. So can you speak to how you're able to use this data to convince governments to make long-term policy changes?
Yeah, that's actually a really, really interesting question. One comment, I know we have to learn, but it's good that we all learn from the way it works in the world. A comment on my name. In Spanish-speaking countries, we use two last names, dad and mom. So Ardila is my mom's last name. My last name is Silva Ardila. So I would be Dr. Silva Ardila. Yes, in terms of having the use of data for long-term policy changes, I think that the one that maybe when you start getting excited about using data, that probably we all haven't, the first answer that came to my mind was patience. Long-term policies require patience. Sometimes there is obvious reasons, there is the reason, we have the scientific arguments, but sometimes that's not the way policy scenarios change. So one of the things is patience, but the other one is understanding that this bulk of information at this moment is working great as a baseline. And now we know that we have the capacity for many years to come to monitor those variables. So the first thing we would have to focus, if we have nothing, is to have those baseline, because we have the certainty that in the coming years, we will start not having photographies, but videos of how our territories change. And that way we can think on the future. And finally, that's a little bit of the field I have been working in my last years, modeling and simulating. And I think there are many solutions, but I think agent-based modeling is really, really powerful tool. For many years, coming from an economic orthodox approaches and synthesizing we are all rational, they ended up in complicated models that do not dialogue adequately to reality. I think agent-based modeling allowed to give this complexity approach to the way cities work and territory works. Thank you.
Yeah, thank you very much, Diego. And just before we leave you on that point, we have lots of questions. One from my side, we talk about policy changes with governments, but what are the traceable relations between the case of using satellite data and policy development, particularly with SDG scenarios?
Wow, that's a really complicated question. But I think, like, in the information and statistical sector, we call something that I think is really interesting to make emphasis on, that data literacy. users need to understand technologies and use them to approach differently the way we observe the phenomena we're observing. The SDG battery is, as you know, a really vast and broad set of indicators. But I think simple things like using Google Maps, like using Waze, like using those things have provided our society with a lot of spatial data literacy. We now understand, and when I say we, I mean broadly, a vast number of citizens understand the potential of geography to understand our dynamics. So we see, and maybe I don't want to extend on the answer to this question, but we can see in local governments, in community organized organizations, in students' projects, that spatial data, and especially remote sensing now with Google Earth Engine, the capacity of running processes faster, start becoming part of the discussions, of the conversation. And I think this is how we can start seeing those traces. Many years ago, it was like you have in English the saying rocket science, and it was like that. Nowadays, it's more citizen science. I mean, we have it, on our desktops, and that really, really modify the way we approach our dynamics and the development of policies.
Dr. Silva Ardila, thank you very much. Now I know two names, so thank you for introducing us to that. But also, I think the fact that these questions are so complex really attests to the fact that it's very complex issues that we're talking about. So we really hope to keep this discussion going. RG, I might turn to you. We have a great question from Bob. Bob, thank you so much for the question from Slido. And Bob asks, monitoring urban SDG indicators are often requires expensive commercial EO data that can't be freely shared. How can we balance market and development concerns?
Yes, thank you, Mino, and thanks to Bob for this question. So certainly commercial satellite imagery with very high spatial resolution offers an opportunity to map built up area in very high detail, in higher detail compared to free and open data sets. And indeed, it's quite challenging to use it, however, especially from a cost perspective. And therefore, we can think of multi-scale approaches in some cases where we can be using the public domain data or that is available either from national built-up inventories or from open EO data sets in complement to potentially some select commercial high-resolution imagery. And so there are certainly some collaborations, at least at the research level, that have been looking at integrating and better combining free and open data sets with commercial data sets, but there is much more that needs to be done in terms of being able to further leverage the commercial sector input and benefits for development issues. And so in addition to the cost issue, there is more that still needs to be done in developing also effective tools and processing algorithms that can help produce consistent data sets for large regions, for instance, in the case of urban, for covering entire large urban areas, so that then this can be used to better infer information on relevant targets and indicators.
Yeah, thank you, Aji. And this also, it reminds me, it's not just about the data, but it's also about the analytics behind that data. So, when we think about capacity building and customizing the data to certain projects, I think that also plays a part in that freely accessible way of doing things. So thank you very much, Aji. Hansdeep, I have a question here from you, from Anonymous. What do you see as some challenges for getting more groups to adopt this sort of method, as opposed to only using the traditional survey methods of doing things? You talked about in some of your projects where you use a geospatial data as standalone, but do you find some pushbacks from some groups to use this as a standalone data source?
Right. Okay. Thank you for the question. Yeah, it is. It is likely that there can be reservations about using this data, and I think the proof of the pudding lies in the eating, and therefore I think organizations like ours that have actually used this data and have had good results. As you may recall, I had mentioned in my presentation that although it started out as a kind of a pilot kind of project or pilot testing, we then eventually found that we could use it with a fair degree of confidence. And I think any resistance, it's normal that there is resistance, right? Especially with evaluators who are, I know we are a pretty conservative lot, and it's not easy to convince us to do different new things, and with good reason, because there are standards and everything set for us to do traditional methods, and setting standards for newer methods takes time. But yes, I think the key to that is more outreach, more dissemination of results. So for instance, after the work I did, I've been able to present my work to on numerous fora. And I have seen a gradual, increase in the use of, such data in our organization and in others. Even yesterday, I was attending another seminar on geospatial analysis. So I think I see that pushback becoming less and less, and especially given these, instant episodes like COVID, which make actually people rethink that we really need to think out of the box and use different methods. And I think I see a lot more use of this in the coming days and months. Thank you.
That's excellent to hear, Hansdeep, and it's really nice to hear that as we continue to have these conversations, we alleviate some of the hesitation that some people might have with using satellite data. Actually, while I have you, I do want you to speak to this particular question that's highlighted on the screen. It's to all of our speakers, but from the point of view as a ex-post evaluation, what are some of the ethical concerns that might arise when you're evaluating projects using this sort of data?
Okay, should I go ahead?
Yes, please.
Okay, all right. So, well, that's a great question. That's a very important question, and in our desire and excitement to use new methods, we actually forget that, especially when it comes to development interventions, we need to see all this through an ethical lens, and I think we forget that. Now, while when it comes to let's say traditional methods that we have been using, so the independent evaluation offices are guided by the UN Evaluation Group standards, UNEG standards, which are very detailed, and for them, in them, ethics is a very important consideration. So it involves like do no harm, kind of a principle, right? So thanks to your evaluation, the people who you've evaluated or interviewed, they should not be left worse off than they were before, simply because they could be targeted by maybe government if they said something against the government or any other organization, and we have to be very careful of that. And I think, in specifically talking about geospatial data, well, right now, as you know, there is a plethora of satellites. You go out there, everybody's monitoring, and you don't know who's monitoring whom. So that remains a challenge, but I think where possible, we should attempt to acquire consent of people. For example, if I am looking at some fields and all, I would make sure that I have, through communities, I've spoken to those groups and mentioned that, there will be something like that and we can share the results, but also we will not be disclosing this to anyone. This will be only for our own purposes. Your names will not be mentioned. Your even the geographic coordinates will not be will not be disseminated. So the whole disclosure kind of arrangement you have to make with them. And I think no matter what type of method we use, ethical consideration should be paramount.
I would 100% agree with that, and I really appreciate your transparency and making sure that everybody understands how their data is being used, how it's being collected, and even how it's being stored in the future. So thank you very much, Hansdeep. RG, I want to also put this question to you. Working at NASA and your other sort of organizations, I'm sure this particular question is always sort of reverberated. So how do you think about some of the ethical concerns when utilizing Earth observation data?
So thanks, Mino. I think primarily, I'd like to start by saying that I think, the primary ethical stance in Earth observations is really making it available for the societal benefit, right? And so it's this utilitarianism concept. Now, I think one of the concerns certainly arises around primarily privacy concerns and ensuring that as we have new Earth observation systems, and in particular with very high resolution data sets like the ones from the commercial sector as well, there is more and more concern that arises around privacy. But at the same time, we are looking at working with organizations and multilateral organizations and ensuring that those concerns are addressed. At the same time, though, we're looking at really focusing on some of the key aspects of data that are really supporting the SDGs and the concept behind the SDGs of leaving no one behind while taking into account these ethical concerns. And so certainly from the point of view of applying the data to enable more transparent and consistent monitoring and reporting, there are certainly, the positive aspects that we try to focus on and highlight and further enable, therefore, the usage of the data for those reasons while taking into account ethical concerns that are being voiced. And I think primarily it is by listening, and one of the things that, I've seen in working with national statistics offices and other organizations that like line ministries and others responsible at the country level is really trying to listen and understand from their perspective what is important, what matters, where are the needs and the gaps, and how can Earth observation data, and if Earth observation data can address those needs and gaps. So really trying to contribute while listening.
Yeah, thank you very much, Aji. I think listening is absolutely key to that. Diego, I'd like to also ask you this question as someone who worked at a national statistics organization and led the organization. What are some of the ethical concerns that are raised there, and if implementing Earth observation data as an additional layer, do you think there would be some eyebrows raised?
Yes, I mean, I will answer a broad question also from a broad approach, and it's like, of course, every use of information has always ethical concerns, but it's not specific of that type of data. I mean, it's about the use of the data. What is it for? Is it, if you're gonna use it to improve the quality of life of the citizens, it's adequate that you use it and protect the privacy and the rights of the citizens that you're using that data for. If you're going to use it to take advantage of them or to diminish the argument that a community has, then you are moving into, it might be the same amount of info, the same type of info, and then you're using it wrong. It's the traditional metaphor of the knife. It helps us for really good things, but it also helps us for really bad things. So we should always focus on how to use it better. Probably I would mention the complication, just to give a more specific detail, the complications that arise in terms of private and public information. I think that if we're gonna build a better world and we want to reinforce SDGs, we have to, maybe I would like to use the word fight in the good sense of fighting, for not allowing to develop boundaries in the information that is required for better planning and for better societies. I don't think, and I can say it with no afraid, that telecoms are the only ones that should have information about the mobility of users of cell phone anonymized. I think national governments should impose requirements that information should be available for planning anonymously, but planning better ways of mobility. I don't think that a right that the government gives to a telecom is then converted into a private good that then society has to buy it again. I think that's wrong. And that's where the question, the third one that I see, crowdsourced data, begin to be really important. And I do think, and I would like to answer that one, is really important that we start moving from only having or providing information in platforms that do not share it, and start using platforms that do share the information and allow us to build a better world. And the ethical questions are always in everything that we do in our societies, and we just always have to make an effort to make it good. And I do think societies try to always do it better than they used to do it, so we can overcome those difficulties.
Thank you, Diego. And you're definitely bringing up some philosophical questions about what is good, what is bad. But definitely we want to go in thinking that whatever data or information we have will be used for good. But also thank you for touching on that crowdsourced data question. We have a number of other questions, but unfortunately we are quickly running out of time. So as we wrap up our webinar today, I'd like to first close by thanking our fantastic panel of experts for sharing their work and their perspectives with us. I think some of these questions really go to show, as I said, how complex these topics are, and I really appreciate each of our panelists sharing their insights. I'd also like to thank you, the audience, for engaging this discussion. As we've done with previous webinars, we'll be following up with our audience with a short survey to continue the dialogue and engage with you. So this brings us to the close of the Serving Society with Space Data series. Our goal was to share knowledge about the utilization of space technologies for data-driven applications related to key humanitarian and development projects, as well as provide guidance for decision makers and showcase examples of work being done, and even highlight areas for more adoption of space applications. So on behalf of the Space Enabled Research Group at MIT's Media Lab and Secure World Foundation, I'd like to thank you all for tuning into the series. All previous webinars, including this one, have been recorded and will be available for you to watch at any time. And I'd like to especially thank our co-organizers, Secure World Foundation, and our tech and comms team, including our fantastic captioners. Stay well and healthy, and I look forward to continuing these important discussions with you all. Bye, everyone.